Hello everyone. Today we're going to go ahead and graph rational functions. This is a part 2, a continuation from yesterday's lesson. So let's go ahead and begin. I have a quick warm-up here. So go ahead and factor this using what you know from Algebra 2. Okay, so go ahead and pause the video and try these examples out while I hide the panels here so I have more space. Okay, so when you're going to go ahead and graph factor these, you've most likely been taught to go ahead and do this, and you pretty much do the guess and check, right? Which perfectly works for some students. But pretty much the main idea behind this is that you're looking for two numbers, right? An A, and let's call this a C, right? An A and a C number that multiply to give you this -5, right? This -5. And that A and that C, when you add them together, has to give you this 4 right here. So let's go ahead and do that. So two numbers that multiply to -5 and add up to 4. So go ahead and give that a try, and hopefully you're able to get that. If I go ahead and multiply a +5 times a -1, I get a -5. And if I was to add them together, I get a +4. So this should be our values, x - 5 and x + 4. So this right here is the same function, but it's going to be in factored form. So this is very, very important, especially when you try to find your wholes, your asymptotes, and stuff like that. Okay, so the next thing that I want to go ahead and show you is today is Tuesday 2.6, and the title we just had it right now. There is tutorials today at 5:15. And I hope that you join. The reason I had to change it from 4:30 to 5:15 is that I had an unexpected meeting and I had to push the tutorials for an hour behind. Okay, so all of these notes, graphing rational functions, are due on Friday, and they should be already on your digital notebook. All you have to do is answer the questions or upload an image. Okay, so let's go ahead and continue. Similar to yesterday, we are learning how to graph and recognize the characteristics of a rational function. Such characteristics like x-intercept, y-intercept, discontinuities, and end behavior. Okay. So these are the expectations for my live classes. Be here on time so we can start on time and use the chat box appropriately. If you were absent yesterday, these are the entire notes. So go ahead and pause the video right here to write down these notes. Okay. If not, you are very familiar because you were here yesterday. Awesome. So go ahead and take a couple seconds to pause the video. And this is a method, the tabular method, on how to factor. And this is specifically when A is greater than 1, right? It's any number greater than 1. So pretty much what I'm saying here is this neat little trick is that you go ahead and get the A, put it in this quadrant, if you will, and you get the C and you put it right here. And then you do the same thing. Sorry, there's A and C, A and C. About that. Don't know what happened. So A and C. Pretty much what we did in the do now, A times C has to go and equal some value. We're gonna call it AC. And what I want you to know is that when you go ahead and find two numbers, right? Two numbers that multiply to A and C, they must add, those same numbers must add to our value that we have here, our value B. Okay, this right here is a 2. So you get two numbers, they multiply to AC, and when you add them together, they equal to B. Once you get those numbers, let's call it these number 1, number 2, whatever those number is, you go ahead and factor them out horizontally and vertically, and you will see. So I said a lot of stuff, but in reality, it's not that bad. So let's go ahead and practice this right here. So we saw that this number right here is my A, goes right here, and I'm going to call it a 2. And similarly, this -2, right, with its sign, is going to go right here. Okay. Alrighty. So pretty much what I said before is that this is your A, this is your B, and this is your C. If you multiply your A term times your C term, you get to see that you have the following. You have 2x squared times a negative 2, and that gives me a negative 4x squared. So that is the numbers. That is the AC, right? This is your A times C is negative 4x squared. Okay, so here's where you guys come in. You have to go ahead and find the number, whatever number, and it's going to go ahead and multiply to another number, and it has to equal negative 4x squared. Those same numbers have to go ahead and add to the term right here, the term b, which is our negative 3x. Okay, so let's go ahead and figure those out. What two numbers multiply to give you that negative 4? Well, hopefully you're able to see that this right here is going to go ahead and give us what? So I kind of blanked out here. But if I do recall correctly, it should be a 4 and a 1, right? So we're going to go ahead and say that 4 x and 1x, right, are going to go ahead and multiply to give me that 4x squared. Now, I'm not done yet because this one has a negative, meaning one of these terms has to be negative. And since this right here has to add to negative 3x, we're going to decide that this right here is a negative 4. So when they multiply, it indeed gives me the negative 4x squared. And when we add 4x plus 1x, it gives me my 3x. Okay, so even I got a little bit confused, but what I want to say here is that you get two numbers, they need to multiply to this term right here, and they need to add to this term right here, the negative 3x. So I got negative 4x times a 1x gave me that. Okay, so we saw that those numbers work. What do we do with them? Well, we go ahead and get these numbers right here, and we're going to go ahead and substitute them right here. So this is our negative 4x, and the other term was a 1x. Okay, sorry about that. I forgot to carry on the x squared, so this is 2x squared. Sorry about that. So exactly as it is. So I'm going to go ahead and erase it a little bit so it's going to a little bit more prettier, and you can see it here. So this was a 2x squared. Okay, so you're probably thinking, what do I have to do next? Well, let me get my little laser so this can be a nice representation. So you're going to go ahead and factor each term. So hopefully you can see the top horizontal. We're going to factor that out, see what they have in common. Then the bottom horizontal, we're going to see what they have in common. Then the vertical left and the vertical right. So each term, we're going to go ahead and find out what they have in common. So let's go ahead and do this in red. So as we said before, this right here, the horizontal on the top, 2x squared and 1x. Both of them have an x. So I'm going to go ahead and factor that. And a 2 and a 1, they're not very nice terms. So I'm going to go ahead and just leave it as x, right? Because the only divisible by those two numbers are both prime. So the only factor they have in common is 1. All right, let's try it again. So go ahead and pause the video and see if you can tell me what these two have in common. So hopefully you're able to say a negative, right? A negative. Then we're able to see that they're both even. So a 2 must be in common. Do they have an x in common? Do both of these terms have an x in common? Well, no. So this is only x minus 2. Alrighty, let's go ahead and go vertically. So vertically right here, what do these two terms have in common? The 2x squared and the negative 4x. So hopefully you're able to see that they're both even, so they have a 2. Then they both have an x. And I think that's pretty much it, right? They're both even, they're both x. Can I factor out a negative? Well, not quite, because only one of them has a negative. So far so good. Okay, how about this terms right here? What do they have in common? There's a negative, there's 1, there's an x, there's a 2, but nothing really. So that must be just the term 1. So in reality, this is the same thing as saying 2x plus 1. Okay, so my answer of this factored is the function right here is the same thing as saying x minus 2, 2x plus 1. This is our solution. This is the same thing as this right here being factored. So pretty neat, right? So go ahead and try this one on your own. So go ahead and practice with this one. Okay. So the same thing goes. You get your 3x, right? The 3x squared. And you replace it right here. So 3x squared. And this minus 2 goes right here. It's minus 2. Okay. What do we do next? You get your A, right? Your A and your C. You multiply them together, so I get 3x squared times -2. That gave me my -6x squared. So here's where we go back to our little guessing game, right? We're looking for two numbers that multiply together to give me -6x squared. And when I add them together, they have to equal this term right here, the b, right? Which is just our x, right? Our 1x. Okay, cool. All right, so go ahead and give those numbers a try. We're looking for two numbers that multiply. Okay, so those aren't that bad. You can go ahead and see that 3x, and when I multiply it times 2x, it gives me my 6x squared, right? Now, keep in mind, one of them has to be negative because our value here was negative. Our 6x squared was negative. So I need something that's going to make this negative, and yet when I add them, they have to equal to just a positive x. So here's where I'm going to go ahead and give you a little tip. The bigger number, right? The bigger number keeps the sign of b. So b in this case is a positive number. So the bigger number of the two factors keeps that sign. So 3x is going to be positive, meaning -2x is going to be negative. And notice how that fixed it. 3x times -2x gave me that -6x squared, and 3x plus a -2x gave me that +1. So these are our numbers. One of them is 3x and the other one is -2x. Okay, so let's go ahead and see what we can compare. So remember, top horizontal, what do they have in common? So I have so I have a 3x squared and a -2x on the top. So we're gonna go ahead and see that this right here has a common factor of x's for sure, right? Because they both have x's. And I don't see anything else. So therefore, the next value has to be a 1. Every term is divisible by 1. Okay, let's go ahead and try the next one. I got 3x and -2x. So I don't see anything in the same. So I'm just going to go ahead and say it's 1. Okay, now let's go ahead and do the vertical left. So let me go ahead and do that in green. So I have 3x squared and 3x. So for sure, 3 is in common. And the top has x squared, the bottom has x. So therefore, x is a factor. Similarly, I'm checking these two. So hopefully you're able to see that there's a minus sign and they both have a 2. So according to this, my factor, right? My factor form of this right here was an x plus a 1. So x plus 1. And this was 3x minus 2. This one's a lot easier to see. So x plus 1 and 3x minus 2. Okay. Alrighty. So this right here is how we factor, and as I mentioned, this right here is a nice way to see all the characteristics. So I'm going to go ahead and pause this video since to just focus about factoring, and I'm going to go ahead and continue the next video on just continuing graphing rational functions. Okay. All right, let me go ahead and end this meeting. As always, guys, it was a pleasure.